Social and economic impacts of AI agents. The increasing integration of AI agents into industries and businesses is having a profound impact on both society and the global economy. AI agents, with their ability to automate tasks, enhance productivity, and make intelligent decisions, are reshaping the workforce, creating both opportunities and challenges. While these technologies offer the potential for significant economic growth, they also raise important questions about employment, job displacement, and the changing nature of work. AI agents and employment. Displacement versus job creation. One of the most discussed social impacts of AI agents is their effect on employment. As AI agents automate more tasks, particularly in industries such as manufacturing, logistics, customer service, and finance, there is growing concern about job displacement. Many routine, repetitive, and manual tasks that were traditionally performed by humans are increasingly being taken over by AI-driven systems. For example, in customer service, AI chatbots are handling an increasing number of inquiries, reducing the need for human agents to answer simple questions or process routine requests. However, the relationship between AI agents and employment is more complex than simple job loss. While some jobs are undoubtedly being automated, new roles are emerging that require human oversight, development, and collaboration with AI systems. As AI technologies evolve, there is a growing demand for workers with skills in data science, AI development, machine learning engineering, and AI ethics. The rise of AI agents is also creating opportunities in areas such as AI training, system maintenance, and human-AI collaboration roles. For instance, AI agents can handle large data sets and perform predictive analytics in financial services, but humans are still needed to interpret the data and make final decisions in complex, nuanced scenarios. This leads to the argument that AI agents will lead to a shift in the nature of work, rather than massive unemployment. In addition, upskilling and reskilling programs are becoming essential as companies and governments focus on training workers for jobs that will coexist with AI technologies. A study by the World Economic Forum suggests that while AI and automation may displace around 85 million jobs globally by 2025, they are also expected to create 97 million new jobs in fields such as AI development, digital marketing, and human-machine interaction. The challenge will be in managing this transition, ensuring that workers are given the opportunities and support to adapt to new job markets and acquire the necessary skills. The economic benefits of AI agents in industries. AI agents bring significant economic benefits to industries by driving efficiency, increasing productivity, and enhancing decision-making processes. The automation of repetitive tasks through AI agents allows businesses to operate more effectively and at a lower cost, enabling them to scale faster and serve more customers without increasing operational expenses. For example, AI-powered robots in manufacturing can work around the clock without fatigue, improving production speed and reducing the risk of human error. In logistics and supply chain management, AI agents help optimize routes, predict demand, and manage inventory more accurately, saving businesses both time and money. Autonomous vehicles and drones driven by AI are transforming delivery systems, offering faster and more reliable services. These innovations allow companies to streamline operations and reduce their reliance on human labor for routine tasks, making them more competitive in a global market. The financial sector is also benefiting from AI agents, particularly in areas such as fraud detection, trading, and risk management. AI agents can process large data sets and identify patterns in real time, allowing financial institutions to detect fraudulent activities, assess credit risks, and make more informed investment decisions. Automated trading systems use AI to execute trades at optimal times, increasing profitability for financial firms. In healthcare, AI agents are revolutionizing diagnostics, treatment planning, and patient monitoring. By analyzing vast amounts of medical data, AI agents can identify patterns that may not be immediately apparent to human doctors, improving diagnostic accuracy and enabling more personalized treatments. The use of AI in these processes reduces costs, improves patient outcomes, and frees up medical professionals to focus on more complex aspects of patient care. Economically, AI agents are projected to significantly contribute to global GDP growth. According to a report by PwC, AI is expected to add up to $15.7 trillion to the global economy by 2030, primarily through increased productivity and the automation of tasks. Industries that adopt AI technologies early are likely to see substantial gains in efficiency and innovation, giving them a competitive edge in the marketplace. In summary, while AI agents raise concerns about job displacement, they also offer opportunities for new forms of employment and economic growth. Their ability to drive efficiency, reduce costs, and open up new markets positions them as a key factor in the future of industry. However, managing the social impact of these changes, particularly in terms of employment and reskilling, will be critical to ensuring that the benefits of AI are shared across society. The role of AI agents in scientific research. AI agents are becoming indispensable tools in scientific research, where they enhance the ability of researchers to analyze vast data sets, identify patterns, and make groundbreaking discoveries. By leveraging machine learning, data analytics, and natural language processing, AI agents assist researchers in streamlining data-heavy processes and pushing the boundaries of scientific knowledge. AI-driven innovation is transforming areas like drug discovery, climate science, genomics, and more, allowing scientists to tackle challenges that were previously beyond human capability. AI agents in data analysis and research assistance. Scientific research, particularly in fields like biology, physics, and climate science, often involves analyzing enormous data sets. AI agents are particularly well suited for these tasks because of their ability to process large volumes of data at unprecedented speeds and to detect patterns and correlations that might be missed by human researchers. For example, in genomics, AI agents are used to sift through complex DNA sequences, identifying mutations and variations that may be linked to diseases. This speeds up the process of genetic research, enabling scientists to make connections between genes and diseases more efficiently. AI agents in this context can analyze vast amounts of genomic data from multiple sources, accelerating the process of discovering potential biomarkers for diseases like cancer or cardiovascular conditions. In climate science, AI agents help analyze vast data sets from satellites, sensors, and historical climate records. By processing this data, AI agents can identify patterns in weather systems, predict climate change trends, and help policymakers make informed decisions about environmental challenges. The ability to simulate complex climate models and analyze massive data sets allows researchers to forecast future climate scenarios and better understand how human activities are impacting the planet. AI agents also assist in scientific literature review by scanning through thousands of research papers, extracting relevant information, and summarizing key findings. These agents use natural language processing, NLP, to identify trends in research, track the development of new ideas, and provide scientists with up-to-date insights in their field of study. This automation helps researchers stay current in rapidly evolving disciplines and reduces the time spent on literature reviews. AI-driven innovation in scientific discovery. AI agents are not only enhancing existing research processes, but are also driving innovation in scientific discovery. By applying machine learning algorithms to scientific problems, AI agents can generate hypotheses, test models, and even suggest new areas for exploration. This capability has the potential to lead to discoveries that might not have been possible through traditional research methods alone. In drug discovery, AI agents are revolutionizing the pharmaceutical industry. Traditionally, discovering new drugs was a time-consuming and expensive process, often taking over a decade to bring a new treatment to market. AI agents now accelerate this process by simulating how different compounds interact with biological targets, predicting the effectiveness of new drugs, and identifying potential side effects. For example, AI-driven platforms like Atomwise and In Silico Medicine use machine learning to analyze chemical data and predict which molecules are likely to make effective drugs, significantly reducing the time and cost of drug development. AI agents are also helping researchers explore materials science. By applying AI to the discovery of new materials, scientists can more efficiently identify substances with unique properties, such as high-strength alloys, superconductors, or materials that can store energy more effectively. AI can analyze data from existing materials and simulate new combinations to find innovative solutions to challenges in energy, manufacturing, and electronics. Furthermore, AI agents are transforming astrophysics and space exploration by assisting researchers in analyzing data from telescopes and space missions. For example, AI has been used to analyze signals from telescopes, helping to detect exoplanets, analyze star formation, and even search for signals from extraterrestrial intelligence. AI agents can process massive amounts of astronomical data that would be impossible for human researchers to analyze manually, making them essential tools in modern astrophysics. AI agents are becoming essential to scientific research by taking on roles in data analysis, pattern recognition, and discovery, providing researchers with powerful tools to accelerate innovation. Their ability to handle large data sets, automate research processes, and uncover new insights is transforming fields as diverse as genomics, drug discovery, climate science, and space exploration. As AI technologies continue to advance, their role in scientific research will grow, driving even more groundbreaking discoveries that will shape the future of science and technology. AI agents in public safety and national defense. AI agents are increasingly being integrated into public safety and national defense systems, where they offer enhanced surveillance, decision-making, and security capabilities. These technologies enable governments and law enforcement agencies to manage security threats more effectively, reduce response times, and handle complex tasks autonomously. However, as AI agents become more deeply embedded in defense systems, they also raise significant ethical concerns, especially regarding the use of autonomous weapons and mass surveillance. This chapter explores the role of AI agents in surveillance and security and the implications of autonomous defense systems. AI agents in surveillance and security. AI agents are playing an essential role in modern surveillance systems, helping public safety organizations monitor large areas, detect anomalies, and respond to potential threats. AI-powered surveillance tools use computer vision, machine learning, and facial recognition to analyze video feeds, identify individuals, and track behaviors in real time, vastly improving the efficiency of traditional security operations. For instance, in urban areas, AI-driven smart surveillance cameras can monitor public spaces and automatically alert law enforcement if they detect suspicious activity, such as unattended bags in airports or unusual movement patterns in crowded areas. These AI agents process vast amounts of visual data from multiple sources, filtering out irrelevant information and identifying high-risk situations without human oversight. This automation reduces the workload on human operators, who can focus on responding to threats rather than constantly monitoring video feeds. Facial recognition technology, often embedded in surveillance systems, is another area where AI agents are heavily utilized. AI-powered facial recognition systems can match faces against databases of known individuals, allowing law enforcement to identify suspects or persons of interest in real time. However, this technology is controversial due to concerns over privacy and the potential for abuse, as well as documented biases that can lead to false identifications, particularly for people of color. Beyond surveillance, AI agents are being used in predictive policing, where they analyze historical crime data to predict where and when crimes are likely to occur. These predictive models allow law enforcement agencies to allocate resources more efficiently by focusing on high-risk areas. While AI can help reduce crime rates, it also raises concerns about reinforcing biased policing practices if the data used to train these models contains historical biases. Autonomous defense systems and ethical concerns. One of the most debated areas of AI's application in national defense is the development of autonomous weapons systems, also known as lethal autonomous weapons systems, LAWS. These are AI-driven military technologies capable of selecting and engaging targets without human intervention. Autonomous drones, tanks, and other weaponry have the potential to revolutionize warfare by enabling faster decision-making and reducing the need for human soldiers in combat zones. However, the use of AI in lethal weapon systems raises profound ethical and legal concerns. The key ethical dilemma revolves around the question of whether machines should be allowed to make life-and-death decisions. Critics argue that fully autonomous weapons lack the ability to make moral judgments and may violate international humanitarian laws, particularly the principle of distinction, separating combatants from non-combatants, and proportionality, avoiding excessive force. Mistakes made by autonomous systems could lead to unintended civilian casualties, triggering humanitarian crises and legal challenges. In addition to the ethical concerns about the morality of autonomous weapons, there are significant security risks associated with deploying AI in national defense. AI agents in warfare systems could be vulnerable to cyber attacks, leading to the possibility of these systems being hacked or manipulated by adversaries. For example, autonomous drones or missile systems could be reprogrammed to attack unintended targets, potentially escalating conflicts. Furthermore, the use of AI in surveillance drones and other autonomous defense systems has expanded beyond traditional warfare to include border patrol, counterterrorism, and domestic security. AI agents can monitor large geographic areas using aerial or ground-based surveillance to detect intrusions or suspicious activities. While these systems can enhance national security, they also pose significant privacy risks, particularly when deployed in domestic contexts. Ethical frameworks and international regulations are critical to managing the growing use of AI agents in defense and security. Organizations such as the United Nations have called for a ban or moratorium on lethal autonomous weapons until a global consensus is reached on how they should be regulated. At the same time, some military powers argue that autonomous systems provide a strategic advantage and are necessary for future warfare. In conclusion, AI agents are becoming integral to public safety and national defense, offering enhanced surveillance and security capabilities while enabling autonomous warfare systems. However, the use of these technologies raises serious ethical and legal questions, particularly regarding privacy, accountability, and the morality of autonomous weapons. As AI continues to shape the future of defense, it is essential to develop global regulations and ethical guidelines to ensure that these systems are used responsibly and in accordance with international law. Welcome to a comprehensive course on AI agents. Here we will discuss what AI agents are, provide some examples of AI agents, explore the technologies behind AI agents, examine future trends, and engage in some hands-on development with popular AI agent frameworks including AutoGen, IBM Bee, LangGraph, CrewAI, and AutoGPT. Introduction to AI agents. What is an AI agent? AI agent is a software entity that acts autonomously to perform tasks or solve problems on behalf of a user or another system. These agents are designed to perceive their environment through sensors or data inputs, make decisions or take actions based on that information, and adapt over time through learning mechanisms. AI agents can function independently or collaborate with humans or other AI systems. Key characteristics of AI agents. 1. Autonomy. They operate without direct human intervention and control their actions based on input data and predefined objectives. 2. Perception. They can perceive the environment through sensors or other data sources, e.g., data APIs, images, text. 3. Decision-making. They use algorithms to make decisions or take actions aimed at achieving specific goals. 4. Learning. Many AI agents incorporate machine learning techniques, allowing them to improve performance over time by learning from experience. 5. Interaction. AI agents can interact with humans, other agents, or software systems to achieve their objectives. Types of AI agents. 1. Reactive agents. These are simple agents that respond directly to stimuli from their environment. They do not have memory or the ability to predict future states. They act based on a set of predefined rules. Example: a vacuum cleaning robot like iRobot Roomba, which uses sensors to detect obstacles in dirt and makes decisions on the fly. 2. Goal-based agents. These agents not only act based on their current environment, but also have a goal that they aim to achieve. They may use search and planning algorithms to decide on the best course of action. Example: pathfinding algorithms used in video games or robots that plan optimal paths to reach a destination. 3. Learning agents. These agents improve their performance over time by learning from their experiences. They can adjust their behavior based on feedback from the environment. Example: AlphaGo, which learns from playing Go games to improve its strategy, or self-driving cars that learn to navigate traffic better. 4. Collaborative agents. These agents work with other agents, or humans, in a cooperative environment. They often rely on communication and coordination to solve complex problems. Example, autonomous drones working together to map a large area or multi-agent systems in logistics optimization. 5. Utility-based agents. These agents make decisions by considering various possible actions and choosing the one that maximizes their utility, i.e., overall satisfaction of their goals or objectives. Example is in financial trading that make decisions to maximize profits while minimizing risks. 6. Hybrid agents. These combine multiple approaches to act both reactively and proactively, adapting their behavior as needed based on both past experiences and future goals. Example: modern AI systems like personal assistants, e.g. Google Assistant, Siri, that respond to immediate requests while also learning from previous interactions to offer better recommendations. Examples of AI agents in use today. 1. Chatbots and conversational agents. Examples: responds to user queries based on natural language understanding. Google Assistant, Amazon Alexa, Apple Siri. Personal assistants that handle tasks like setting reminders, controlling smart devices, and answering general knowledge questions. 2. Autonomous vehicles. Examples: Tesla Autopilot uses AI agents to process sensor inputs, predict traffic conditions, and navigate autonomously. Waymo, self-driving technology developed by Alphabet that uses a combination of AI, sensors, and planning algorithms. 3. AI in video games. Examples: non-player characters, NPCs, in games use AI agents to respond to player actions, move strategically, or offer challenges. AlphaStar, an AI agent developed by DeepMind that plays StarCraft 2 at a professional level by learning complex strategies. 4. Recommendation systems. Examples: Netflix and YouTube use AI agents to recommend shows and videos by analyzing user preferences and behaviors. Spotify suggests music based on past listening habits using AI agents that analyze audio features and user data. 5. Financial trading. Examples: high-frequency trading algorithms, AI agents that buy and sell stocks in milliseconds based on real-time market data. Robo-advisors, AI agents that provide automated investment advice by analyzing financial data and customer goals. 6. Healthcare. Examples: IBM Watson Health, AI agents that analyze medical records, research papers, and patient data to assist in diagnosis and treatment. AI-driven diagnostic tools, agents that scan medical images like X-rays or MRIs to detect diseases like cancer. 7. Robotics. Examples: Boston Dynamics robots. These robots use AI agents to navigate, perform tasks like walking and jumping, and make decisions autonomously. Robotic process automation, RPA, in industries. Software agents that automate repetitive tasks like data entry or customer service operations. Technologies behind AI agents. 1. Machine learning, ML. AI agents often use ML algorithms to learn from data, adapt to new situations, and make predictions or decisions. Techniques like reinforcement learning are critical for agents that need to learn from trial and error, e.g. robots game-playing agents. 2. Natural language processing, NLP. Used in conversational agents and chatbots, NLP helps AI agents understand, generate, and process human language. Examples: GPT models, BERT, and transformer-based architectures. 3. Reinforcement learning, a type of ML where an agent learns by interacting with its environment, receiving feedback in the form of rewards or penalties, and adjusting its actions to maximize rewards. Examples: AlphaGo, DQN, DeepQ networks, and self-driving vehicles. 4. Neural networks. Deep learning techniques, particularly neural networks, enable agents to recognize patterns in data, whether in images, text, or sensor inputs. Convolutional neural networks, CNNs, are common in image processing, while recurrent neural networks, RNNs, and transformers are used for sequential data like text or time series data. Examples: visual recognition agents, NLP agents. 5. Robotics and control systems. These technologies allow AI agents to physically interact with the world, like grasping objects or navigating through complex environments. Examples: humanoid robots, autonomous drones. 6. Multi-agent systems. In environments where multiple agents must work together or compete, Mass focuses on communication, coordination, and decision-making between agents. Example swarms, AI in cooperative video games. 7. Cloud computing and edge AI. Many AI agents rely on cloud-based infrastructure for processing and storage. Edge AI pushes some of the computation closer to the devices themselves, reducing latency for real-time applications. Examples: AI-powered IoT devices, autonomous drones with onboard AI processing. Future trends in AI agents. General AI. While current AI agents are specialized, research is advancing towards general-purpose AI that can solve a broader range of tasks with human-like adaptability. AI-augmented creativity. Agents capable of generating creative works like art, music, or literature, assisting humans in creative tasks. Ethical AI. As AI agents become more autonomous, ensuring they adhere to ethical guidelines, e.g. fairness, privacy, and safety, will become crucial. AI agents are a vital part of the ongoing revolution in AI, with applications ranging from personal assistants to self-driving cars. Their autonomy, ability to learn, and decision-making capabilities have transformed various industries and will continue to evolve, shaping the future of technology. For the hands-on, I will hand it over to Vivian Aranya, who will go over implementation details for AutoGen, IBM Bee, LangGraph, CrewAI, and AutoGPT framework.
Thank you, Thomas, for the introduction. And now we will jump into AutoGen. AutoGen is an open source AI framework developed by Microsoft to facilitate the creation and management of multi agent systems. These systems enable multiple AI agents to collaborate in solving complex tasks autonomously or with human feedback. AutoGen is designed to streamline the development of multi agent workflows by simplifying agent communication, coordination, and tool integration. Some of the key features include multi agent conversations. AutoGen allows agents to interact with each other through structured conversations, enabling them to solve problems collaboratively. Agents can communicate, use tools, and even execute code depending on the task. We have agent customization. You can design agents with specific capabilities and roles, such as an assistant agent for general tasks or a user proxy agent to simulate user behavior or handle specific workflows like code execution. Agents can be configured to use different large language models LLMs like GPT-4 and integrate tools for code execution, file handling, or API interactions. Human in the loop. AutoGen supports human intervention when necessary. This feature allows humans to provide input, review decisions, and guide the process when automated decision making requires oversight. Code execution and tool use. Agents in AutoGen can run code and use external tools autonomously. For example, you can create a task where an agent generates code, executes it, and even debugs it autonomously. AutoGen Studio. For users who prefer a low code environment, AutoGen Studio provides a user friendly interface to define, test, and deploy multi agent workflows without deep programming knowledge. You can visualize agent interactions, track performance, and export workflows as APIs for integrations into larger systems. Next, let's look at some use cases. So we have the code-based task automation. AutoGen can be used to automate code generation, execution, and debugging tasks, reducing the need for human intervention. We have collaborative multi-agent workflows. It is ideal for orchestrating tasks where multiple agents collaborate, such as research, content generation, or troubleshooting. Enhanced customer support. AutoGen can be deployed to create AI driven customer support systems where multiple agents handle different aspects of the interaction, such as problem diagnosis and resolution. Finally, let's jump into the hands on where we will chat between user proxy agent and an assistant agent. Let's get started. So, start with let's open terminal. So, I'm going to open terminal, make it a little bigger so you can see clearly. Go to my desktop folder. I'm going to create a virtual environment here by saying python -mvenv and I'll call it autogen environment. And once it's created, I'm going to say source AutoGen env is the name that I gave, env slash bin slash activate this environment. And now I'm in this environment. Now first thing, oops, let me clear it out. First thing that I want to do in this environment is install AutoGen. You can do it by saying pip install py AutoGen, and that will install our Python AutoGen. It will take a few seconds. It's not that big, so it should be pretty quick. And once it's done, I'm going to clear it out again. And now I'll write the code that can define agents and set up conversations between them. So let's open Sublime Text. I'm going to save it on my desktop. I'm going to call this testing.py, and in here I'll start writing code. So first thing is from AutoGen import assistant agent and user proxy agent. Now what did we type here? Now this line imports two classes. One is the assistant agent and user proxy agent from AutoGen framework. Now the assistant agent is represents the AI assistant agent, which acts autonomously based on the given configuration. And the user proxy agent represents the user in the system. It simulates user behavior by sending inputs to assistant and interacting with it. Example, asking questions and giving commands. Next step. Next, what I'm going to do is I'm going to create a variable llm underscore config equal to, inside here I'll say specify what model I want to use. I'm going to go over this again to GPT dash. I think the one that I have access in my OpenGPT is for O dash mini. That's what I have paid for. If you have no idea how to use this, just go to OpenAPI and create a key, and it will give you instructions on that, and then use your API key. Now here I'm going to use my API key. I'm going to leave it like this for now because I don't want to share it with everyone on YouTube. So I'm going to keep it something like this. So just to go over again here, uh, we have created a configuration dictionary uh, which is created for language learning model LLM, and the model specifies the model being used, in this case OpenAPI's GPT-4o mini, which is the model that I'm using, key value pair. And then API key refers to the API key that allows the agent to access the GPT-4o model. This key is unique to me, and it is obtained from OpenAI's API management portal. You can probably do get yourself. To get there, you can open a browser and just say Open API key, and then it will take you to OpenAI's website where you can sign up and get a key. So that's the next step. The next step is let's create the agents. So first agent that I want to create is assistant agent equal to, I'll say assistant agent. That's how you, oops, sorry, not a quotes, the assistant agent. And in here it takes parameters name assistant and llm underscore config equal to llm underscore config from above, and I'll create user underscore proxy equal to user proxy agent, user underscore proxy, and code underscore execution underscore config equal to, set this false, capital F. And so what am I doing here? So in this particular line, I'm creating the assistant. I'm using the assistant, first one, assistant agent class, where I'm providing an attribute assistant. The agent is this. So in this particular case, I'm giving the agent a name assistant for identification, and the LLM config equal to LLM config. What I'm doing there is the LLM configuration from the previous step is passed to the assistant. This tells the assistant which model to use, or GPT, which is GPT-4o Mini, and provide the necessary API credentials. The assistant will now have the ability to use that model for processing tasks such as responding to queries, generating text, and making decisions. The next line, which is user proxy, where we are giving a name user proxy to the user proxy agent class, and this agent will simulate the actions of user interacting with the system. The code execution config equal to false. This configuration disables the code execution feature. By setting this to false, the agent will not be able to execute any code as part of the interaction. If you wanted the user proxy to execute code, you would need to configure this with a specific execution environment like enabling Python or shell execution. The next step in this case is to initiating the chat. So what I'm going to do is I'm going to say user proxy dot initiate, if I can spell it right, underscore chat. I guess that's the right spelling, initiate. Yep. And then I'm going to pass the assistant that I'm going to initiate chat with, and message equal to, in this case I'm just going to give a message saying tell me a joke about tech, let's say stocks. So let's save this. So that's kind of it. And in the last statement, what I'm doing is I'm starting the conversation between the user proxy and the assistant agent. The user proxy dot initiate chat. The initiate chat method is called on the user proxy agent, asking it to start a conversation with the assistant agent. The user proxy sends this message as the first input, asking the assistant to generate a joke about tech stock. The assistant will use GPT-4o model to understand and respond to this query. Let's go ahead and run this and see what happens. So I'm going to save it. I'm going to go to my folder here, and then I will run. Maybe I might be missing some stuff. So let's see what we are missing. Say Python, and the name of the file was testing.py. So it looks like I am missing sklearn here. So for doing that, let me clear it out. Now for sklearn, we have to give this command pip install -u skikit learn and skypy and matplotlib. So I make sure everything is available just in case if something is missing later. I don't have to get that back again. It's going to take some time and install all those libraries. And once I'm done, let's try again one more time if I'm missing anything. Oh, I'm missing xgboost, so I am going to say pip install xgboost. Also, remember I forgot to go back. I forgot to add my API key, so I'm going to add the API key right now. I'm going to remove this. I'm going to take my key and paste it here. So my key is pasted. Now I'm going to go back and run it. And it started starting the conversation, tell me a joke about tech stocks. And the user proxy started with it. And assistant said to user proxy, why did the tech stocks break up with its significant other? Because it couldn't handle the volatility. Terminate. Replying as user proxy, provide feedback to the assistant. Please enter to skip and use auto reply, or type exit to end the conversation. I can press enter, and it says no human input received using the auto reply. It seems you are interested in the blank response. Enter a blank response if you have any questions or tasks. To assist you, I'm going to say, what is the capital of Italy? And it says the capital of Italy is Rome. It answered me. So now I've created a chat agent here, which so user proxy is me, and then the assistant is going to answer based on the question that I have. So this kind of gets us to a point where we have successfully tested AutoGen AI agent. So if you have any questions, leave me in the comments, and I'm going to move to the next framework. The next agent framework that we have is the IBM Bee agent framework. Now, IBM's Bee agent framework is an open source platform developed to build and manage scalable AI agents and workflows. It allows developers to create agents that leverage various large language models, LLMs, and tools to handle complex tasks in an efficient and structured manner. The framework is designed to be model agnostic, meaning it supports different AI models and it is not tied to any specific provider, helping developers avoid vendor lock in. Now, what are the key features of the B agent framework? First, modular AI agents. The framework comes with built in agents or allows developers to create their own, making it highly customizable. Your tool integration. B supports a variety of tools for tasks like web search, example DuckDuckGo, and weather retrieval, example OpenMeteo, and we are going to check these ones, which can be integrated into workflows. Memory management. The framework offers different memories strategies, optimizing the agent's ability to retain state between interactions while keeping token cost low. Sandboxed code execution. You can safely execute code within sandbox environment, making it suitable for applications requiring computational task or code interpretation. Traceability and observability. B provides visibility into the inner workings of agents, allowing developers to trace all actions, interactions, and decisions made by the agent. Persistence. Workflows can be paused and resumed without losing state, ideal for long running tasks or workflows requiring human in the loop interactions. Error handling and caching. The framework includes robust mechanisms for managing errors and optimizing repeated actions through caching, ensuring reliable agent performance. Also, something to know is B's multi agent approach allows complex tasks to be broken down and handled by specialized agents which work together under the guidance of an orchestrator. This makes the framework powerful for enterprise applications like software assistance or autonomous flows. To get started with B, you can install it via npm or yarn, define agents using its built in tools, and deploy them to serve real time requests. B is also integrated with popular LLMs such as OpenAI, making it suitable for applications across a variety of domains. So let's get started. Here is a step by step guide. So, how do we use B agent framework to build and run an AI agent? There are a bunch of steps that we'll follow. First step is installation. Step 2 is import and set up the agent. Step 3 is invoke the agent. Step 4 will enhance with observability. Then, step 5, I'll show you how to run it locally. Step 6 is advanced usage. And step 7 is deploy and monitor. So, let's get started into the hands on. Step 1 Installation. You need to install the B agent framework via npm or yarn. This will set up the necessary components to build and run agents. So I'm going to just give you one example. I'm going to open terminal, make it a little bigger so it's visible. And here I can say npm install b dash agent dash framework. Run this and this will install our B framework. Now, if you want to use yarn, you do the same thing, yarn add b dash agent dash framework. So that's the command for that. Once this is done, what you can do is you can import and set up the second step, which was import and set up the agent. So what I'm going to do is in the next step is which is importing the necessary modules and create your agent. You can use pre-built tools like DuckDuckGo search or OpenMeteo for weather queries. So let's go ahead and create a quick example of how to do that. So I'm going to open Sublime Text. I'm going to save this on my desktop. I'm going to say b btest.js. It's JavaScript file. Let's make sure that everything ran fine here. So it was installed. That's good. Now here I'm going to run the commands. I'm going to import first one to import the B agent. What I do is B agent from where is it available? It's available in my B dash agent dash framework slash agents slash b slash agent. So that will import my B agent. Next thing that I want to do is import. We'll import the OLLama chat LLM. So for that, I'll say OLLAMA chat LLM from, again, this comes from the same one, but oops, B agent framework, and inside there we have adapters, and inside adapters we have, this is one of the adapter in there, which is OLAMA slash chat. So that will take care of that. Perfect. Next one that we need is the token memory. Import token memory, and this comes from, again, same B agent framework. B agent framework slash memory slash token memory slash, I think that's, yeah, token memory. Next, I need to get DuckDuckGo search tool, that I can say import DuckDuckGo search tool from, again, same B agent framework slash tools. It's inside the tools folder of that, and it's inside search, and it's the duck go search. So this will help you with searching stuff. And then last one, I was said that open meteo tool. Okay, so we'll do open for weather. This is what is used, meteo tool from, and luckily these are available in our Bee framework, so we don't have to actually write any of these tools. And this is under weather, and inside weather it's open meteo. So that will take care of all our imports. Now next is initializing the LLM memory and tools. So I'm going to say constant LLM equal to new. This is my LLM chat, OLAMA chat. That's what I use. So in this, use a specific LLM model, which in this case what we're using is the Llama 3.1. So that should make good for our project. Memory, I am going to say new token memory, and this needs my LLM, so I'm going to pass the LLM as the parameter inside, so that's good. Next, I need my tools, which is the DuckDuckGo search and open meteo. So I'm going to say new DuckDuckGo search tool and new open meteo tool. So that's that. And finally, let's set up the Bee agent. To set up the Bee agent, I'm going to say constant agent equal to new Bee agent, and this Bee agent needs parameters, which is LLM, it needs the memory, and it needs the tools. So I'll provide those. That's good. So this is how you can import and set up the agent. So next step in this particular project is to invoke the agent. Now if you want to invoke the agent, you can run the agent to handle user queries. Here's how you invoke the agent and retrieve the results. In this case, the agent will provide the current weather in a specific location using the open meteo tool. So I'll show you that example. I'll just write it here below itself. I want to open another file. Response equal to await, and I'm going to call the agent that I've created, and this, inside this I can new agent, and I'll say dot run. This is the function that I'll call over there. These are the different parameters or callback methods that it has. I'm going to say prompt is, I'm going to say what's the current weather in Atlanta, and I will say observe. Observe, inside my observe function, I will send an emitter. This will observe whatever happens, and I'll say emitter dot on. When it fires up, I am going to say update is async. Second parameter needs an async, where it will provide back the data, the update, and the metadata for that, and this will come back inside the function that will write, which will say console.log, and inside that I can use the special quotes, and I'll say agent and pass the value here, update dot key inside there, and close this and give slash this, and then pass update dot value in here, value in here. That's all I need to do. So this will make sure the observer is on. And finally, after everything is done, let's make sure that like to make sure my semicolons are properly closed, and then I'll say console.log, and inside this I'll say agent response. What was the response of this query here, comma, response dot result dot text. Let's move it up so you can see clearly. Response dot result dot text. So this will help us invoke the agent and get the data out of it. Now step 4 in our case was to enhance with observability. Now if I want to add some more observability to the agent, what I'm going to do here is so what Bee provides is a built-in observability feature, so you can trace the decision-making process of your agent. To use this feature, you can integrate the observer to log the intermediate steps. So what I'm going to do is I'm going to say agent dot observe, which is similar to this here, agent.observe emitter, and I'll remove the update and method. Update, it passes the data, console.log, and you can just say update, and here pass the data that we got. So this is an example of adding an observer to log updates in real time. So that you can add it here on your server side where you're writing that code. Step 1 is run locally. Step 5 is to run locally. So to run the agent locally, you'll have to follow different steps. First step is to clone the repository if you want to work for examples. So that is available in, I think, Bee agent framework in GitHub. So I can, it's called IBM Bee agent framework. I hope this will give me, yep, there you go. That's the one. So you can clone this one. I can copy this and can go here and say go to my desktop for now, and I can say git clone git at the rate the usual command is I can directly get it from there, but I can just say github.com:i Bee framework dot git, enter. So it will clone my, could not read from the repository, permission denied. I think I have not added my GitHub, but this is the command to kind of get it from there. You can also get that command from here. You'll probably see you can also download it directly. If you don't want to clone it, you can download this. If I click this, it will download the zip for me and I'll have it. Or you can, of course, as I mentioned, you can clone it to your from this particular repository location, which we did. So that's the first step. Next step is to install the dependencies. So you can just say yarn install to install the dependencies. Next, to start the agent, the command is yarn run start Bee. So that's how you can start this. So this is how you can run a Bee framework locally. Next step, or step 6, is to is the advanced usage. Now Bee allows you to create dynamic tools, manage workflows, and include human in the loop mechanisms. For advanced use cases, you can explore different features like this custom tools where you can create your own tools by defining specific functions your agent can execute. Then we have memory strategies where you can adjust memory settings to handle long running sessions and token optimization. We also have code execution. B supports code interpretation in a sandbox environment, useful for executing Python or JavaScript code dynamically. Let's look at example of a custom tool. You can create a custom tool to add more functionality to your agent, like how we use the tools which were available, which were our DuckDuckGo and OpenMeteo. You can also create your own tools. For that, first you'll have to, let me just say, import. You can import the tool from, now where do we have our tools here? For example, I'll just copy this here because most agents, and then from tools, that's what we do. Now if you want to define a custom tool, I can say constant, I can call it, let's say, custom tool. And what does my tool do? I can give that, use that tool, and then pass the name of the tool, custom tool, and then I can create the functionality of what it does. So first thing that I need to provide is description, and description is custom tool to handle, let's say, specific tasks. And I'll have to give the run of what happens when someone runs it. Async, it takes the input in, whatever input is provided, and in here I will handle that and return, let's say I'll call it handled task with input, and say dollar input. So that's my tool. Now to add it to the agents tool, what you have to do is below it you can say agent dot add tool, or we have created the agent below, so it's always best to after the agent dot add tool, and I'm going to say new, whatever the name of my tool is, which is custom tool. So now we have three tools here: DuckDuckGo, OpenMeteo, and the custom tools added to our B agent. Next, let's look at next step. Next step is deploy and monitor, where once you have built your agent, you can deploy it and monitor its performance. The B framework supports integration with monitoring tools to track agent performance in production environments. So that kind of completes our step-by-step hands-on for the B agent framework. If you have any questions, let me know in the comments, and I'll get back to you. And let's move to the next next framework. The next agent framework that we're going to look at is LangGraph. Now, LangGraph is a specialized framework within the LangChain ecosystem that focuses on building and managing stateful multi-agent applications using large language models, LLMs. Its key purpose is to orchestrate complex workflows where multiple agents can collaborate or work independently to achieve specific tasks. Unlike simpler agent frameworks, LangGraph allows for more control and flexibility, making it suitable for applications where agents need to manage complex decision making processes, incorporate human feedback, or handle various domain specific tasks. Some of the key features of LangGraph include cyclic and branching workflows. LangGraph supports loops and conditional paths, allowing agents to revisit previous states or adjust their behavior based on new data, making it ideal for complex problem solving or continuous tasks. Persistence and state management. It automatically saves the state of the agent's work, enabling features like error recovery, resuming tasks, and even time travel where you can edit past actions. Human in the loop. This feature allows agents to wait for human approval before proceeding, giving businesses control over critical decisions. Then we have integration with LangChain and LangSmith. While LangGraph operates independently, it integrates well with LangChain for LLM orchestration and LangSmith for performance monitoring. Streaming support. LangGraph supports streaming outputs, making it suitable for real time interactions such as chatbot conversations or dynamic data processing. And finally, the multi agent and hierarchical systems. It allows for creating teams of agents where each agent performs specific tasks or collaborates with others, with some agents managing or supervising others. Let's look at LangCloud and example use case of LangGraph. The LangCloud is the complementary service that allows developers to deploy their LangGraph applications at scale. It supports features like asynchronous job handling, scheduled tasks, and deep monitoring capabilities, ensuring that these agents can operate in large scale production environments without bottlenecks. Next, let's look at some of the example use cases. First, customer support automation. LangGraph can manage customer support tasks by employing multiple specialized agents. One agent might handle general queries, while others deal with specific tasks like troubleshooting or refund processing. Autonomous coding assistance. Replit uses LangGraph to develop coding agents that assist users by generating and debugging code. LangGraph ensures these agents work reliably in production environments. Complex workflow automation. Organizations like Norway Cruise Line use LangGraph to build guest facing AI solutions that manage workflows, require dynamic, real time decisions based on customer interactions. Let's jump into building an agent using LangGraph. The steps that will fall is here are: first, we'll set up the environment. Step 2 is define the agent's tools and functions. Step 3 is create the agent logic. Step 4 will build the graph. Step 5, add persistence. Step 6, invoke the agent. Step 7, extend with multi agent or complex workflows. And step 8 is deploy. Let's get started. Step 1, set up the environment. First, we need to install the necessary packages and configure our environment. So let's open terminal, increase the size, and here I'm going to say let's create an environment. I'm going to go to my desktop and I will create Python -m v virtual environment, and I'll call it LangGraph, and then I'll activate this by saying source LangGraph /bin/activate. Once I have that, let's clear it out and let's install pip install LangGraph, and I need LangChain, and I will also install OpenAI. So once this is done, I will also make sure, let me clear it, export OpenAI underscore API underscore key equal to, you add your OpenAI key here. So I'll probably add mine here, and then let's say my API key, press enter. So you should have, if I say code $OpenAI underscore API underscore key, it should give me my API key that I've added. I'm going to change that and add my own, but make sure that you add your own OpenAI key here. Now that's step 1. Let's clear it out. Now step 2 is to define the agent's tool and functions. That's what we mentioned. And for that, let's go ahead and so what happens is agents typically rely on tools, example API calls, search functions. In this step, we'll define the tools our agent will use. So what I'm going to do is I'm going to open my Sublime Text, and here I'm going to say from, first let me save it as lang test.py, and here I'm going to say from LangGraph, which I downloaded the library .graph, I am going to import my state graph and message state or messages state. So that's those two things. I will also need tools. So I'm going to say from langchain underscore core, that's where the tools are. I'm going to say import tool. Next I need is a tool node, which is available in LangGraph, and it's a pre-built item. So I'm going to say LangGraph dot pre-built BUILT import, and I want to import, as I said, tool node. So that's what I get from here. And then from Anthropic, I'm going to open the get the chat Anthropic. So that is available in langchain underscore Anthropic. I am going to import chat and Anthropic model. So that's kind of gets our basic libraries. Next, we have to define a tool that simulates searching the web. So I'm going to just start with @tool. That's what I'm going to call it. I'm going to say function search, and this search function needs a parameter. Let's call it query type string, and here this function is, let's here add some simulate a web search. Let's call that. Okay, that's good. Next, I am going to say if, that's for example weather in query dot convert it into lower case, then in this case return, I will just say it is sunny, and else return no data available. That's good. So that's my tool definition. Now below it I'll say tools equal to search, and tool node equal to tool node pass tools to it. So that kind of defines a tool that simulates searching the web. Next step is, so this kind of completes our step 2, which is defining the agent's tools and functions. Next, let's create the agent logic. Now you need to set up how your agent interacts with the environment. This could include calling models and defining conditional logic for decision making. So let's define the model the agent will use. So I'm going to go back here, and here I'm going to say model equal to the one that we downloaded, chat Anthropic, and model I will say equal to, I will use Claude, and I think it goes like this, Claude 3.5. So the version of the mod, and Sonnet is if I'm not, let's see, let me look at my 202 406 20, that's the one. And then I probably have to say temperature, how hot I want it to be, and I will say it's 0, and I'm going to say bind this to tools, bind tools, that's the function, and pass tools to it. So that will define the model the agent will use. Now next thing is defining the function that calls the model. So I am going to call it call model, and it takes a parameter state, which is message state, and this function I am going to create a variable messages equal to state. From state itself I will take the parameter messages, and then response equal to model dot I will invoke based on these messages. That's how you do it, and then I'll return it. I'll say return messages. You kind of create a JSON and pass the response to it like that. Next thing is we need to do conditional function to decide whether to continue or stop the agent's workflow. So that I'll create another function, just make some space, auto added something. So I'll say define should it continue, and that takes the parameter state, and that state is also message state, And in here, I will check if state of, let's say, messages of -1 dot tool underscore calls, then I will say return tools, else I'll say return end. That's it. So that will kind of decide whether to continue or stop with the agent's workflow. Now, once this is done, this kind of continues our stops our step 3, which is create agent, save it, create the agent logic. Next is building the graph. So now we have to use LangGraph to build a state graph for our agent, connecting the nodes, which are the tasks, in the workflow. So we'll have to start with the workflow. Let's say our workflow equal to state graph. Come on, state graph, and it takes the message state. That's how you define the workflow. Get the workflow from there. Now add nodes from the agent and tools. For that, what you'll have to do is in workflow, I'll say add node. So this is how you add nodes, and call, let's say, agent is call model, and to add workflow dot add node, to add the tools, we'll call the pass the tool node. So that's how you add nodes. And then finally, we'll define the transitions between nodes. To do that, I'll say workflow dot add underscore edge. That's how you start, and give the command start with agent. And then this is start with the agent. And next one is workflow, I think, dot add underscore conditional edges. It depends. So I'll say agent and should I continue. So this will check if we need to continue. And next one is add edge, and this is for the tools. So I'll say tools comma agent, and this after using a tool go back to the agent. So that's what I'm saying here. So that kind of completes our step 4, which is build the graph. Now add perspective. Now this is add persistence. Sorry, add persistence is optional. You can add a memory saver to ensure the agent state is kind of preserved between execution. This is useful for long running tasks or tasks involving human interaction. So for this, you'll probably need another library. I'll say from LangGraph dot checkpoint. That's what we'll use, dot memory, because that checkpoint is what has the memory library. And I'm going to say import. From this, I'll import the memory saver. So this is one of the method that is available in there. Now I need to initialize the memory saver. So I am going to do it. Let's put it here somewhere. I'm going to say checkpoint ter equal to memory saver, and then so this is initializing the memory saver. Now I'm going to compile the graph into a runnable application. We'll say app equal to workflow dot compile and pass the check pointer equal to check pointer. So let's actually, since we're taking workflow, I'm going to go at the bottom here. So this will make sure that between executions it will save the states, and if it has more options, it will probably make sure the states are saved. So the next step in this particular building or LangGraph is invoking the agent. Now with the graph compiled, you can now invoke the agent with a user query and observe how it responds. So for that, I need something from LangChain core dot messages. What I need is I need to import something called as human message. Now we need to start a conversation with the agent. So I'm going to go at the bottom and I'm going to say final state equal to app dot invoke. That's how you invoke this particular app. And here inside this, I'll say messages. Okay, messages is human message content equal to what is the, let's say, what is the weather today. What is the weather today? And then once I have that, I need a config which is, I'll say, configurable state equal to, I'll say, thread ID. I have to pass the thread ID of some unique number. I'll say this unique thread ID for state persistence. That's what we are doing here. We're making this configuration. And finally, let's print the final state in here and say messages of -1 dot content. So that will print the response from the agent. So that's it. That kind of covers our step 6. And now step 7, which is to extend the multi-agent or complex workflows. Now LangGraph supports multiple agent designs, allowing you to connect multiple agents in a hierarchical or collaborative manner. You can further extend your graph to include multiple agents or integrate more complex conditional logic such as waiting for human input before proceeding with tasks. Anyway, the additional features include human in the loop, where LangGraph allows you to pause execution and request human approval for specific action before the agent continues. Also, a state management, where LangGraph's persistence feature ensure you can pause and resume workflows, making it suitable for applications requiring long running tasks or human collaboration. And finally, the step 8 is to deploy. Like for scaling, LangGraph Cloud enables easy deployment of agents with features like task scheduling and monitoring. With tools like LangGraph Studio, you can debug and monitor your agent's performance in real time. So that kind of concludes our LangGraph uh, framework, where we learned that LangGraph provides a flexible and powerful framework for building AI agents with sophisticated workflows. By following the steps above, or whatever we did, by following these steps, you can create an agent that uses tools, calls models, handles decision dynamically, and persists state across executions. Now, if you have any questions on this or you had any issues with this, let me know in the comments and I'll get back to you. Thank you. Now that we have covered AutoGen, IBM Bee, LangGraph, let's jump into CrewAI. CrewAI is a platform designed for building, managing, and deploying multi agent AI systems. It enables multiple autonomous AI agents to work together seamlessly, performing complex tasks collaboratively. These agents can assume specific roles, share goals, and interact efficiently, much like a well coordinated crew. Some of the key features include role based agents. Each agent in CrewAI can be assigned a specific role and goal. For example, one agent could act as a researcher while another serves as a writer. These roles can work together to complete complex workflows such as generating content or analyzing data. Processes. CrewAI supports different process types. Sequential process. Tasks are performed in a predefined order where the output of one task can serve as the input for the next. We then have hierarchical process where agents operate under a manager agent which coordinates the task, reviews results, and allocates resources. And then we have consensual process where agents collaborate to make decisions and agree on task execution, introducing a democratic decision making process. We have tool integration. CrewAI supports integrating various tools to help agents complete tasks. These can range from web searches to specialized data tools, and the platform supports connecting agents to different LLMs like OpenAI, Mistral, or local models via APIs. Memory systems. CrewAI includes sophisticated memory options such as short term, long term, and contextual memory, enabling agents to remember past interactions and learn from them over time. And then we have real world applications. The platform is used in diverse fields, including strategic planning, healthcare, marketing, finance, and supply chain management. It helps automate tasks such as content creation, customer sentiment analysis, and predictive marketing. Let's look at some of the example usage of Crew AI. An agent crew could consist of a research agent tasked with gathering information on the latest AI trends and a writer agent that composes a blog post based on the research. These agents work together in a sequential process where the output from the researcher becomes the input for the writer. CrewAI's flexible design allows it to be deployed on premise, in the cloud, or integrated with various apps, offering teams the ability to automate workflows without needing deep programming expertise. Now, let's look at step by step for using CrewAI for building multiple agent workflows. The steps that will follow is first we'll install CrewAI, then we'll set up the environment, then we'll define the agents, then we'll create some tasks, and then we'll define the crew and processes. Then we'll run the crew. Let's jump into it and see how we can implement these steps. Step 1, install CrewAI. Let's start by installing CrewAI on our system. You can do this using Python's package manager. You may also want to install optional tools that expand agents' abilities. I'm going to open terminal, increase the side. I'll go to desktop, clear this out. I'm going to create an virtual environment, call it crew, and I'll activate this crew. So by saying source crew slash bin slash activate, clear this out, make it a little bit more bigger, and here I'll say pip install crew AI. Straightforward. It's going to download and install in my environment. It's going to take a little bit time to install this. So once it's done, we will be going and installing some extra tools by saying install crew AI tools. So that takes care of installing Crew AI, which is our step number 1. Next step is to set up the environment. So now set up any necessary API keys for the models and tools you plan to use. Crew AI supports models like OpenAI's GPT-3, GPT-4, and many others. You can use environment variables to configure these keys. We have already added the OpenAI API keys in the previous library that we saw. But if you want to do that, again, you can just say export open AI underscore API underscore key, and then here add your OpenAI key, whatever it is. So that will make sure that you have your OpenAI key installed. Next thing that I want to do, I already have done that, so I'm not gonna do this again. I'm gonna make sure that it's clear. And next step is to define agents. Now, agents are the core of Crew AI. Define each agent role and goal in the workflow. You can also specify the tools they will use, their ability to delegate tasks, and their verbosity. So, I'm going to start with a Python file. I'm going to open Sublime Text and save this file on my desktop. Call it crew test.py. And here I'm going to, from Crew AI library, I am going to import agent. I'm going to import task. I am going to import the crew, and I am going to import the process. So, and from the CrewAI tools that I have, I will import SERP Serper Dev tool. Make sure that's there. And now I am going to define a researcher agent. So the way I do it is, as I mentioned, there's one researcher agent. So that is, this is how you probably do it. I'll give it accordingly a proper role. I'll say role equal to, say, senior research analyst. That's his role. We can also give, as I mentioned, role and goal. And the goal for this is research cutting edge AI advancements. That's what it does. And backstory, let's give it a backstory. Backstory for this agent is you work at a tech think tank analyzing AI trends. That's what this agent does. Next, let's give it, let's say if it's verbose true or false. So I'm going to say verbose is true, so as verbose as possible. Tools that I want to use in this case is I want to use a Serper dev tool, pass it as a parameter. Next thing I want to do is define the writer agent. So writer is something similar. I mean, agent is an agent, just that this is a writer agent, and this guy role is content strategist, and his goal is to create engaging content from research that researcher has done. As I mentioned earlier, you are a skilled writer, uh, transforming research into engaging articles. That's what this guy does, this writer does. Verbose is true. I'm not going to use any tools here. So that kind of defines our agents. Next thing is creating tasks, as we see here. Fourth is creating tasks. Now, for creating here, we define the tasks that the agents will perform. Tasks can include attributes like descriptions, expected output, and responsible agent. So, if I want to create a task, let me just put some space here. So task 1 is a task. So this is we are creating a research task. In this case, we will give something. So the parameters are description. We'll give expected output, and we will say which agent will work on this. For this one, the agent is the researcher. So I'm going to pass this as the agent here. Now let's start with description. Description equal to, move this down, I am going to say analyze AI advancements in 2024 and provide a detailed report. So this is his task that we are providing. Now, what is the expected output from this particular task? Is a research report in, let's say, bullet points. So it's properly bulleted based on the description that it said. I guess this is what we are expecting back. Now let's create a writing task for the writer. Just move a little bit up. I'll say task 2 equal to, again, task, and we need 3 items, these 3 items. I'm going to pass that here, and in this description it's mostly for the writer to write an article. and then our agent here will be, of course, the writer. Expect the description is, let's ask it to write a blog post based on the research report, and the expected output that we have is full blog post, and we can also say at least 4 paragraphs. So we're expecting more, but we're saying best at least do some. So this is how you can define or create your task. Now next thing is defining the crew and the process. Now you can now assemble your agents into a crew. The process defines how tasks are executed, either sequentially or hierarchically. Now, sequential tasks are completed one after the other in the order they are listed, whereas the hierarchical is where is a task is where a manager agent oversees task execution, delegating task, and reviewing the results. So let's define the crew. I am going to move everything up and say crew equal to crew. In this particular case, we will say which are the agents in this particular crew. We have only 2 agents, so we are going to pass those guys as the crew agents. Next is tasks that are required. So we created only 2 tasks. I'm going to pass them here, task 1 and task 2. So that's our task. Now, what is the process we follow? We'll say process dot sequential, which means one after another, because a writer will actually write something after the researcher provides the report, and then verbose equal to true, as detailed as possible. So there you go. That's kind of completes our step 5 where we define the crew and the process. Now finally, run the crew. Once your agents and tasks are defined, kick off the crew to start working on the task. You can observe the output and adjust the process flow as needed. So here I am going to say result equal to crew dot kickoff, and then output of the final results we can print it out by saying final output is, say, print result. There you go. This should print our final results. So if I want to run this now, I can go open my terminal, and here I can say python crew test.py. That's my file that I've created here. And once I run it, what it will do is it will run those tasks as senior analyst and senior research assistant thought search input. It's kind of calling my OpenAI API and calling this and creating getting the research and also writing the blog. If you see, the blog has been written, and as you can see, it automatically did all these things based on the steps that we have followed, where we defined agents, created tasks, and you see the output it here based on, and what it used was it used the OpenAI API and called all these methods out there. So that kind of concludes our Crew AI. If you have any questions on this, let me know. If you had any issues following along, let me know in the comments and I'll get back to you. And let's move to the final one. Let's look at our last AI agent framework, which is AutoGPT. AutoGPT is an experimental open source application based on OpenAI's GPT-4 model. It is designed to automate the process of generating human like text by chaining together reasoning tasks. AutoGPT is capable of autonomously performing tasks that typically require multiple prompts and user inputs, thus streamlining processes that would otherwise require human oversight. Some of the key features of AutoGPT include autonomous task management. AutoGPT allows users to define high level goals and it autonomously breaks down these goals into smaller tasks, executes them, and iterates until the goals are met. It can autonomously prompt itself for additional information or perform actions without requiring continuous human input. Internet access for research. It has the ability to search the web, gather information, and analyze it to complete tasks. This feature is especially useful for tasks that require up to date or broad research. Multi agent collaboration. AutoGPT can deploy multiple agents with specialized roles. These agents can collaborate and exchange information to solve complex tasks similar to multi agent frameworks like AutoGen. Memory and file management. MotoGPT can create, read, and modify files autonomously, making it suitable for tasks that involve managing large datasets of information or gathering code and documents. Plugins and API integration. AutoGPT can integrate with various APIs and plugins to extend its functionality, such as automating tasks related to e commerce, marketing, or project management. Some of the use cases and limitations of AutoGPT include: for use cases, we have business automation. AutoGPT can automate tasks like customer service inquiries, market research, and content generation. Programming. In programming, it can assist with code generation, debugging, and even executing scripts autonomously. Personal assistance. Users can set up personal tasks like managing calendars, setting reminders, or handling emails without continuous supervision. Some of the limitations include complex task understanding. While AutoGPT can handle many tasks autonomously, it may struggle with high complex tasks that require nuanced human judgment or creative decision making. Cost. Since AutoGPT operates through the GPT-4 API, continuous use can become expensive due to API call costs, especially for long running processes. Now, to implement AutoGPT, you can follow these steps. AutoGPT is a Python application that leverages GPT-4 to autonomously complete tasks based on user defined goals. So here are what steps we'll follow. First, we'll install the prerequisites, set up the OpenAI API keys if you have not done it in the previous steps. Then we'll configure AutoGPT settings. Then we'll run AutoGPT. Then we'll define goals and tasks. Then we'll do supervise AutoGPT. Then we'll enhance AutoGPT with plugins. And finally, we will monitor and adjust. So these are the steps that you would follow. So let's jump in and see how we can do this. Step 1: Install prerequisites. AutoGPT requires Python 3.10 plus, and you need to set up API access to OpenAI's GPT models. So, first, we'll clone the AutoGPT repository. So, for that, you can go to terminal, or you can open the browser and go to AutoGPT Git. I'm going to just type that, and that should give me the AutoGPT Git. I can go here and just download that. So I've downloaded that on my desktop here. I can open it here where I can see the entire project right here. So to install it, you can directly download from this particular place, and also all the entire steps to build and use the agents are described here in this particular video. You can play this and you can probably see how to go ahead and install and run then an auto GPT, and it kind of gives you a sample here. So that's the entire thing that I'll follow, but that's the first step: installing prerequisites. Next, set up the open API AI API keys. We have done this a couple of times in the previous framework, so you can go through that and look at that if you want to, how to add it to your environment variables. Next step is configuring AutoGPT settings. Now you can configure AutoGPT with environment variables and tweak its behavior. Some of the key settings in environment file include the continuous mode or memory backend mode. That's what you can add. Continuous mode is AutoGPT can run continuously without human approval, whereas memory backend is choose a memory backend like Redis, Pinecone, or local memory for long-term memory. Next is step 4. Now, if you want to run AutoGPT, you just say Python -m AutoGPT, and it will run it based on the environment that you have set in the previous steps. And that brings us to step number 5, where you define goals and tasks. Now, when AutoGPT starts, it will prompt you to define a name for the AI. which example you say research bot, and then a role that explains what the AI is supposed to do. And then you can set up to 5 goals that the AI will work towards autonomously. For example, research the latest trends in AI, write a summary report, create a PowerPoint presentation, so it all does it for you. Which brings us to step 6, which is supervise AutoGPT, which is an optional step. But in default mode, AutoGPT will periodically ask for confirmation before proceeding with certain actions. If you want AutoGPT to run autonomously without manual intervention, you can enable the continuous mode by adding it into your environment variables when prompted. That brings us to step 7, which is enhance AutoGPT with plugins. Now, AutoGPT supports various plugins and tools for additional functionality. For example, Pinecone for memory storage, useful if you want to use your AI to remember context over long periods. Lemon Labs is another one for text to speech, which enables the AI to speak its responses. You can configure these plugins in your environment files. And finally, step 8, which is monitor and adjust, where AutoGPT logs its progress and outputs tasks as it completes them. You can monitor and adjust its settings or restart the process with new goals as necessary. So we can go back to this where you can probably see everything that you need to do to set up AutoGPT at this particular URL. You can just search for AutoGPT and you'll get this as the first result in Google. So I hope this works. And if you have any questions, let me know in comments and I'll get back to you as soon as possible. Thank you.